Loudly, apparently.
We have a question here at Lawrence, if you have a minute.
Sure.
As far as homework goes, they don't know how to turn it in. Should they get it to you Sunday night, give it to me Monday morning?
Well,
Either,
it's
or
it's
let me get
not
in the camera.
it's not due till Monday. So I would
Okay.
never assign something due on a day we don't have class. So it's
So
always due.
if they give it to me Monday morning, it's okay if I scan it after class to get it to
Absolutely.
you? Okay,
Yep.
perfect.
Yeah.
Thank you.
Yep. Yeah. I received a bunch of homework assignments via Blackboard. And email. Again, I have to just ask that you double space these assignments. I need room to write in between the answers. Like especially some of these where you just put the answer right next to the question. I've got no room where I can write, so I need to be able to do that. So these assignments should be in Times New Roman, 10 to 12 point font, and double spaced. Okay? Let's see who's here. Where's my little map? What happened there? Okay. Let's see. Trisha. Check. Madison. Check. Let's see. Peyton. Olivia. Sam. Anna. Mason. Abigail. Raya. Kira. Let's see. Claire. Connor. Jill was there a minute ago. Emily was there. Marley was there. Ariel is there. Lexi is there. And Maria is there. So the only person missing is Jack, and we knew he was going to be. Okay. So did everyone hear what I said about the assignments?
Yep.
Okay. Especially come on now. Okay, when it comes like this, see, I have no room to write. And I need to be able to write, because if I don't think you understand a question, I need to make sure that after I give it back to you, you have a pretty good understanding of it. So I need it to be double spaced. Any questions before we move on to chapter 2? Okay. Chapter 2 is on psychology's scientific method. Remember we said that the important elements of the definition for psychology included the term science. The fact that it is a science and we use the scientific method to study it. And so, scientific method is something you should have studied in school around the 7th grade. But for some people in college, 7th grade was longer ago than for others. So we have a chapter that presents the information kind of as a way of just making sure everyone's on the same page and making sure we're all aware of the basic terminology that's required. So some of the things discussed in this chapter include, the scientific method itself, the types of research, samples and settings, analyzing and interpreting data, the ethics of research, again, thinking critically. Remember I said that's going to be an important element all throughout the book. And then lastly, that health and wellness portion. We start all chapters with a definition. This particular chapter, we're going to use that same definition from chapter 1. Psychology is the scientific study of mind and behavior. Okay? Of behavior and mental processes. So, when we talk about science, science is a method of study. It doesn't matter what you study that makes it a science, it's how you study it, okay? You can study anything in a scientific way or in a non-scientific way. So science is not defined by what it investigates, but by how it investigates. Using the scientific method is what makes psychology a science. Researchers in psychology use the scientific method when conducting research. They propose theories to try to explain what's going on in the world. A theory, which I will come back to a little bit in a few minutes, is a system of ideas that attempts to explain observations and help us to make predictions about future observations. Scientific theories are rejected or supported or refined using the scientific method. The scientific method follows the following 5 steps: observing some phenomenon, formulating hypotheses and predictions, testing through empirical research, drawing conclusions, and evaluating those conclusions. Let's start by taking a look at step number 1, observing some phenomenon. The first step in conducting scientific research is observing some phenomenon, acting like a detective, wanting to know why or how something is the way that it is. When trying to formulate a research question for your observation, it is important to operationally define how your variable will be measured. Our definition for variable is anything that can change. It's what it is that we're looking at. So if we're looking at students' grades when involved in sports and not, our variables are grades and sports involvement. Okay? The scientific method, as I said earlier, begins with a theory. A theory is a broad idea or set of closely related ideas that tries to explain certain observations. They tell us about the relationship between variables on a conceptual level. Theories try to explain why certain things occur, and they make predictions about future observations. The second step in conducting scientific research is stating a hypothesis. A hypothesis is an idea that is arrived at logically from a theory, but it's formatted in the form of a prediction or a statement that can be tested. So we say to ourselves, the grades of students involved in sports are not as high as the grades of students not involved in sports. And we structure that in the form of a prediction. If you're involved in sports, your grades will be lower than if you were not. Okay? The third step is conducting scientific research in order to test the hypothesis by collecting and analyzing data. Collecting and analyzing data is referred to as empirical research. The researcher must decide what participants to use in their research. Oh, I'm sorry. It's like they're pumping something into this room to put me to sleep. Human, animal, male, female. In the case we're talking about now, we're talking about students. Do we want all students, high school students, elementary school students? Do we want students we easily have access to, or do we want random students from any school? By establishing an operational definition, the researchers provide an objective description of how a variable is going to be measured or observed. It's important to remember that variables themselves have multiple potential definitions. And so the operational definition is simply the definition that you, as a researcher, are choosing to operate with during your particular research. So when we say involved in sports, that needs to become more specific. What's a sport and what's not? What's involved and what's not? So if someone is an equipment manager for a sport, do we consider them involved in a sport? Well, we have to decide that. It takes up the same amount of their time, right? It's taking them away from other things. So those are decisions you have to make in creating your operational definition. The operational definition needs to be so specific that someone could come in right behind you and read your definition and repeat your experiment exactly. Okay? A key aspect of testing a hypothesis is the data collection, which applies, this should say data analysis. I keep meaning to change that in the notes. Which applies mathematical procedures to understand what the data mean. When we say data, we're talking about any information that we collected during the study. The next step is drawing conclusions. Bless you. Based on what was found after the data analysis, researchers can draw conclusions from their research. After publication, replication is key. Having other researchers repeat your study and getting the same results is important in psychology because it adds strength, weight, reliability to your results. There are two types of replication. Direct replication involves doing the study exactly as it was conducted previously, and conceptual replication, which involves doing the same study but with different methods or different samples, changing it up a little bit to see if it changes the results or not. A research finding is considered reliable when the study has been replicated again and again and continues to yield similar findings. And the last step is evaluating the theory. Evaluation never really ends. The conclusions that you draw become part of the research community, which continues to question them because they are scientific thinkers, they are psychological thinkers, they are critical thinkers. Meta-analysis is a statistical procedure that summarizes a large body of evidence from the research literature on a particular topic. So let's say what you're interested in has been studied before. You may be able to go and find a bunch of those studies and use their data, combine them together to strengthen the reliability of the results. That's called meta-analysis when you do that. With meta-analysis, researchers combine results across various studies to establish the strength of an effect. Your book gave you an example. A recent meta-analysis of 33 studies of academic performance sought to answer the question of whether procrastination affects academic performance. And in the individual studies, it did, but when you put the 33 studies together, the strength of the effect of the procrastination was higher. Psychologists work together in a collaborative effort to increase an overall body of knowledge. Researchers can work together on the same study. They can share their scientific findings by publishing them in scientific and academic journals. Researchers can also share their conclusions by presenting them at both international and national conferences. Questions about any of these 5 steps? None. So if we had a pop quiz on them right now, you'd get it? Okay, Ariel.
What was the other kind of replication again? There was direct replication and
Conceptual, meaning you're using the concept, but you're not doing the study exactly the same. So we call it conceptual replication. Claire, were you going to say something?
No.
Thought I saw someone else moving around. Okay. No other questions? Okay. We're going to talk about the types of psychological research. 3 main types of psychological research are descriptive research, correlational research, and experimental research. Descriptive research is just like it sounds. It describes the data. The goal is to describe the phenomenon that you're interested in. Come on. An important way to do that is through observation. Being a good observer requires an important set of skills. Observers are trained and they practice their skills regularly. When you train to become a psychologist, you become an astute observer of people and things. It's just something that you aren't able to turn off at a certain point. In order for observers to be effective, they must be systematic. The researchers must know what they are looking for, who they are observing, where and when the observations will take place, and how the observations will be made. If not, if I sent 3 or 4 of you out to go observe aggression on a playground, and I didn't explain what you're looking for, who you're going to be observing, where and when the observations would take place, the 3 or 4 of you would come back with very different data, which would not be able to be used together. And so this is part of that operational definition of being very clear about what we're measuring and how we plan to measure it. One method for getting information from people is to interview them directly. When information needs to be taken from a large group of people, a survey can be used. A survey consists of questions about a person's self-reported attitudes or beliefs about a topic. Survey questions can be either unstructured and open-ended, like, what's your favorite color? Or they can be structured and more specific, like, choose one of the following as your favorite color: red, blue, yellow, green. What's the problem with the first type of question, open-ended and unstructured? If someone were to ask you, what is your favorite color? Anna?
Sorry.
It's kind of going to be all over the place, and you won't have very clear results.
Absolutely.
So many.
You'll get answers like turquoise, okay? Where do you file that? Is that under blue or is that under green? Remember, your data has to be quantifiable in order for you to do data analysis at some point. And so you're going to have to, if you're very open-ended and unstructured, you're going to get answers that are all over the map, and you're going to have to make decisions about where to put them. That introduces a certain level of bias, okay? So that can be the problem with having your questions open-ended and unstructured. But what's the problem with having them structured and more specific? Kira?
They don't always, not everyone is, like you said, red, yellow, green, or whatever the examples were. Not everyone falls under those categories.
Your answer might not be there. And so, essentially, what you're being asked is no longer what is your favorite color, but instead, what color do you prefer best of these 4? Which is a very different question, right? And different people might not know how to answer that question. Whenever you ask people questions about their own attitudes or beliefs, you're taking a couple of assumptions into play. First of all, that they've ever thought about it, okay? Have you ever asked someone their favorite color and they're like, geez, I don't know. I never really thought about it, okay? So if you ask them, you're assuming that they have thought about it and that they know the answer. So if you ask them and they've never really thought about it and then they choose an answer for you just for the purposes of your study, is it really the truth? Who knows, right? And secondly, you're assuming that they plan to tell the truth in the first place, okay? Let's say you're doing a study about child abuse and grades, and you decide to stop people in the mall. How many people are you going to be able to ask, do you abuse your children? And they're going to be like, yeah, I just did before I got here. How many people are going to answer something like that truthfully? So not only do you assume that they've thought about it before and that they know their own answer, but that they're planning to tell the truth, right? Some people would prefer to look like a better person rather than to answer truthfully, depending on what you're asking. So surveys and interviews can be problematic because sometimes participants will answer questions in what they believe is socially acceptable or socially desirable instead of how they feel. Okay? Another type of observation is called a case study. A case study or case history is conducted when a researcher takes an in-depth look at a single individual. Case studies might also provide an in-depth and detailed exploration of a particular small group like a family. The case study is usually conducted by a clinical psychologist. It's usually done when the unique aspects of an individual's life cannot be duplicated in others. Okay? So let's say you're doing a study on people who have been traumatized by a natural disaster. Well, you can't do an actual experimental study and cause a natural disaster for some people, right? You just can't do that. So you're going to need to go out and find people who have already experienced a natural disaster. Now, while there may be a lot of people who've experienced natural disasters, that doesn't mean that their situation is not incredibly unique. And it doesn't mean that they don't all want to participate in your study. So in that case, you might want to, if you find someone, you might want to perform a case study, okay, rather than trying to collect 100 people who've been affected by natural disaster, okay? Also, when a situation is particularly rare. If you've ever heard of dissociative identity disorder, we used to call it multiple personality disorder till we understood it a little bit better. Now we call it dissociative identity disorder. It is incredibly rare. It is clinically diagnosed in 0.001% of the population. So it is very rare to actually have a legitimate clinical diagnosis of dissociative identity disorder. So it's difficult for us to collect information on 1,000, 500, or even 100 people who have dissociative identity disorder. But we still want to study it. So when we find even one person who has been diagnosed with it, we may want to do an in-depth case study on that person to learn as much as we can. Through doing this, we have learned a lot about dissociative identity disorder. For example, we've learned that most of the people who have been clinically diagnosed have had some form of severe physical or sexual trauma in their childhood. And so, as psychologists, that's important information. It means that should we have someone in in therapy with us, and we think that we're seeing some symptoms of dissociative identity disorder, and we see a connection to severe psychological or physical or sexual abuse in their childhood, we can make that connection. However, does it mean that every single person with dissociative identity disorder has been abused in their childhood? Who answered? What'd you say?
No.
No. Does it mean that every person who has been severely physically, psychologically, or sexually abused in their childhood is going to develop dissociative identity disorder?
I hope not.
Right. So, even though we can learn valuable information from a case study, it's not information that can be generalized and applied to a larger group of people. Does that make sense? Okay. So, case studies can tell us a great deal about an individual person, but not very much about people or larger groups of people in general. Descriptive research allows researchers to get a sense of what something is, but it cannot answer questions about how or why it became that way. Your textbook gives you the example of a study that was done using the satisfaction with life scale. This was where a bunch of researchers went and interviewed thousands of people from all of these different countries. And they used a scale called the satisfaction with life scale. And they used people's scores on this scale to determine their happiness. Okay? So the variable they were measuring was happiness. The operational definition for this particular experiment was their score on the satisfaction with life scale. And they published this large scale study, and not only in academic journals, but in a lot of popular media as well. And it showed that the United States was actually fairly low, much lower than they thought, on the happiness level. It also showed that some third world countries were much higher than you would have thought they were, and were much higher than the United States in terms of their happiness. The problem with this, when it was released to the general public, is that people started filling in the blank as to why the groups got different scores. Okay? Why do you think the United States might have a lower score in happiness? Kira.
The influence of media on our lives.
In what way? It's just generally more negative?
Yeah, and we see a lot more of the negative in all parts of the world, let alone just our lives. And
Okay.
It's not all positive.
Okay. Araya?
I noticed that a lot of the questions were about goal based and where are you on achieving your goals in life and stuff like that. And for Americans, our goals might be like larger things that aren't as achievable as in many third world countries.
Yeah, a lot of Americans are on what we call the hedonic treadmill, where we're always looking for the next best thing. So we're never really truly satisfied. Jill, what were you going to say?
I was just gonna say that like different, like less fortunate areas probably have a different outlook on, they've learned to appreciate the smaller things.
Absolutely. So, the United States in general has become very materialistic, right? We chase after, the next best thing, the next science thing, the next future technology advancement. Whereas people in third world countries, they're happy to wake up alive, right? They're happy to be able to have clean drinking water that day, okay? Another issue that gets ignored is this issue of operational definition. How many people actually think satisfaction with life and happiness are the same thing? Anybody? How many people think that they're different enough that people may have misunderstood this study? Okay, it's possible, right? There are, I am a fairly happy person, but there are many days when I'm not necessarily satisfied with my life and what's going on, and I want to make changes, right? So there are a lot of issues with this study, and what people have to step back and look at is that it is just a descriptive study, okay? It is only describing what the situation is. That why was a matter of everybody else guessing, okay? Trying to fill in the blanks. Because why was never attempted to be answered, okay? And operational definitions are important, okay? The satisfaction with life scale is one example of what researchers use to help operationally define variables, in this case, the variable of happiness. If researchers wanted a more in-depth understanding of the predictors of happiness, they would turn to a correlational design, which brings us to our discussion of correlational research. In correlational research, the goal is to identify relationships or correlations between the variables that you're measuring. Correlational research is conducted when studies are concerned with identifying the relationships between two or more variables so that it can be understood how the variables change together. In a correlational study, the variables are measured by the researcher to see how they relate. The strength of the relationship between two variables is expressed as a correlation coefficient, or the letter R, sometimes referred to as Pearson's R, which is a statistical term. This correlation coefficient has two parts to it. It has the numeric value and it has a sign. The numeric value of the correlation coefficient always falls somewhere between -1 and +1, where the number actually determines the strength of the relationship or the magnitude of the relationship between the variables. And the sign, positive or negative, determines the direction of the relationship between the variables. And I'm going to explain that more. But for now, the plus or minus sign describes the direction of the relationship. If something has a positive sign, we say it is positively correlated. If it has a negative sign, we say it is negatively correlated. The closer the number is to 0, the less of a relationship there is. At 0, there is no relationship between the two variables at all. At 1, whether it's negative or positive, at 1, it is a perfect relationship, which means that these two variables change with each other 100% of the time. And we have this scale we use. From 0 to 0.25, we would consider a weak correlation. 0.25 to 0.50, we would consider that a moderate correlation. From 0.50 to 0.75 is strong. From 0.75 up to 1 is very strong, and 1 is perfect. Now, back to those terms, positive and negative. Your textbook has decided to show you how to understand correlations using something called scatter plots, which give you a visual representation of the data. And it can make it much easier to understand correlations. A positive correlation occurs when the variables move in the same direction. So that if one variable increases, the other variable increases as well. If one variable decreases, the other variable decreases as well. So take a look at this scatter plot here. You would expect a positive correlation because the longer the lecture is, the more people are going to yawn. That's represented by this dot up here. The shorter a lecture is, the fewer times a person's going to yawn. That's represented by this dot here. So we go out, we do some research, and this is the data that we collect. Do you see how these dots are trending in an upward direction? That's why we call it a positive correlation. They're going upward. As one variable goes up, the other goes up. As one goes down, the other goes down. Okay? So whenever you see this kind of a trend in a scatter plot, you're looking at a positive correlation. Now let's look at a negative correlation. A negative correlation occurs when the variables move in opposite directions. So that if one variable increases, the other variable decreases, and vice versa. Here we have an example of the longer the lecture, the lower student attentiveness is. So at the beginning of the lecture, when we first get here, it's the shortest lecture, we get a lot of high attention. Everybody's paying attention, right? But as the lecture gets longer, we see people are paying less attention. We're getting lower attentiveness, okay? When we collect the data plots look like this, and you see the trend is going in the opposite direction of the positive correlation. The factors are varying in the opposite direction. Now, if you're not a visual person, and you're looking at this scatter plot and you're saying, all I see is dots, that's fine, okay? The scatter plot is here for the person who needs the visual representation. If the visual representation confuses you, all you need to remember is that a positive correlation means as one variable increases, the other variable increases. They vary in the same direction. And a negative correlation means that the factors vary in the opposite direction. So as one increases, the other decreases. Questions? Olivia? No.
What if,
Yes.
yeah. What if, like, when you collect your data
Mm-hmm.
and it doesn't have, like, a solid, like, direction that it goes in, like positive or negative, what would you do?
Then the strength is probably low. Okay, if your numbers are all over the place, then those variables may not have a relationship to each other at all. So remember we looked at the magnitude 0 to 1.
Oh, okay.
Number will probably be low. Other questions? Okay. So, correlational studies can take place anywhere, whether it's in the classroom, out in the real world, or in the laboratory. Words like link, associated with, relationship between, these are all synonymous with correlations, but do not mean causation. Correlation does not equal causation. A correlation between two variables only states that there is a relationship between the two variables and not that one of the variables causes the other. Now, your slides give you several examples. This one here about parental harshness and child rebellion. Another one about a happy mood and sociability. And I think there's one more. Nope, okay. I think a much better example is a study that I was actually exposed to as a kid. A study was released when I was a kid in the popular media, okay? So I didn't see it in journals. I don't know how it was presented in journals. But in the popular media, it was announced that as ice cream sales increase, so too do drowning deaths. Some of the lesser educated people in my neighborhood started not allowing their child to go to the ice cream truck. Okay? This study was repeated multiple times, and every time it was done, it showed that as ice cream sales increase, so too do drowning deaths. Do the ice cream sales cause the drowning deaths? Do the drowning deaths have something to do with the ice cream? What'd you say, Edmiston? I
So I hope not.
Okay. So what is a possible better explanation for the existence of this correlation? Araya?
Ice cream sales would probably go up in summer, and that's when we're supposed
Yeah. Statistically, ice cream sales tend to go up in the summer, and so too does swimming. Once swimming goes up, drowning increases. Okay? So the issue here is that there is a third variable that is causing the relationship, and that is the season or the weather. Okay? The third variable sometimes presents us with something called the third variable problem. The third variable problem occurs when an extraneous variable that has not been measured accounts for the relationship between the two other variables. In this case, we call this third variable a confound. Even though there's always a risk of a third variable, correlational studies are still important because they allow us to research variables that cannot be manipulated. And we'll talk about that next time in a experimental method, we have to manipulate the variables. When you can't manipulate the variables, you can still perform correlational studies. Correlational studies can also be conducted on variables that would be considered unethical to be carried out in an experiment. Okay, in an experiment, you have to take two groups that are very similar, put one through one thing and another through another. So if you wanted to observe the effect of abuse on grades, you'd have to take 200 kids, abuse 100 of them, and not abuse the other 100. That's unethical, so you can't do it. So you would do a correlational study instead. You would go out and you would find kids who are already abused, and you would compare their grades to those of kids who are not abused. And most of these studies are done in what we call a cross-sectional design, which measures variables at a single point in time. Although correlations do not allow us to show causal relationships, they do allow researchers to make predictions among variables. It's also, again, valuable in cases where that might be unethical to do research in any other way. Correlations are helpful for researchers studying everyday experiences such as natural disasters, like the earthquake that caused a tsunami in Japan, or the earthquake that struck Guatemala. Correlations can also measure multiple variables in their studies. In some cases, a researcher can assess whether a relationship between two variables is explained by a third, fourth, or even fifth variable. When studying everyday experiences, we use something called the experience sampling method. This means we track people's daily experiences in their natural setting. Alternatively, we can use something called an event contingent design, which means instead of people recording what happens to them all day, every day, they simply record when a specific event occurs. Another option in correlational research is using a longitudinal design. Longitudinal designs are a special type of systematic observation that measures variables of interest over time. One example of a longitudinal study in your textbook is the study between happiness and longevity, using the Nun study data set that was conducted by David Snowden and his colleagues. Even though longitudinal studies attempt to demonstrate causality, even the most well-constructed, excellent longitudinal studies cannot prove causation. In order to prove causation, we require experimental research, which we'll talk about next time. Questions? All right, I'll be here for the next 2 minutes if you have any questions.